Sabines formula. Sabines formula is an important formula in acoustics which gives information regarding the reverberation time. According to Sabines formula, reverberation time is given by 0.196 V divided by sigma AS, where V stands for the volume of the hall or room in meter square. A is the absorption coefficient of the surface area of different materials present in the wall, and S is the surface area. There are some assumptions that are made before applying Sabines formula. The distribution of sound energy is uniform in all parts of the hall. There is no interference of sound waves in the hall. The absorption coefficient is independent of the sound energy and also the frequency of the sound wave. There is no loss of energy in air. What exactly is reverberation time? The time that the sound takes to fall in intensity by 60 decibels or 1 millionth of the original intensity after the source has been stopped is called as reverberation time. This is what we are going to find out using Sabine's formula. So before starting, we are considering a small element ds in the wall AB, where ds is going to act as the source, and we are like considering a shell of radius r from this ds surface. And in the small angle d theta, there is a small surface, and this thickness of the surface is given as dr, and the arc length is going to be given by r d theta. Therefore, the area of the shaded portion is going to be r theta d theta dr. And so this region, which can be thought of as this cone over here, this region, this radius is r, but this radius is going to be r sine theta. So when we are shifting that area from this point to this point by a minute difference, this length that has been traveled is given by dx, and this dx value is going to be equal to r sine theta into d phi, this distance. And volume traced by the shaded portion is going to be r sine theta into d phi into area of that. So this into this area. So r dr d theta into r sine theta d phi, which is going to give the volume element dv, r square sine theta d theta d phi dr. If E is the sound energy per unit volume, then sound energy present within the elemental volume dV, that is the volume that we just discussed, is E into dV. E into substituting the value of dV that we got from the previous expression, E r square sine theta d phi dr. The sound energy from elemental volume is traveling equally in all directions. Therefore, we are taking the solid angle value to be d phi. Uh, this particular sound energy will travel in all directions. So, the particular sound energy value in one solid angle is going to be given by E r square sine theta d phi dr divided by 4 pi. Solid angle subtended by area ds at the elemental volume dV is given by ds cos theta by r square. Therefore, the sound energy from the elemental volume, which is going towards ds, will be given by this angle into energy of one solid angle. So we are multiplying both these terms. For integration, we are considering that theta changes from 0 to pi by 2 and phi changes from 0 to pi, r changes from 0 to v or c, which is the speed of this light. And yeah, so we are integrating this entire term. When we integrate d phi, we are getting as 2 pi, and dr, we are getting v. V will be later replaced by c, which is the speed of light, as I already told. Then if we integrate sine 2 theta, we'll get cos 2 theta divided by 2. And after all the calculation, we end up with E ds v divided by 4. which is going to be the sound energy falling on ds per second from the volume dv. So the total sound energy absorbed by ds is going to be ev ds divided by 4 into absorption coefficient, which is a, and total sound energy absorbed by the entire hall will be sigma a ds, where s is the surface area of all the surfaces and a is the absorption coefficient. So EV capital A divided by 4, where capital A is the summation ADS. Growth and decay of sound energy. We are assuming that total decay of sound energy at a hall is given by EV, where E is the energy of the sound wave at one particular volume, V is the total volume of the hall. Total growth or increase in sound energy per second will be given by differentiating EV, which will be V into d by dt, as d is going to remain constant. Rate of emission of sound energy by source is equal to rate of growth of sound energy in the room plus rate of absorption of that particular sound energy by the walls in the room. So, which is going to be given by rate of emission of sound energy is denoted by P, which is equal to V dE by dt plus ECA by 4. P is equal to ENCA divided by 4 on rearranging these terms. And we are setting dE by dt is equal to 0 because we are considering the growth of sound energy in the steady state. When energy max value is reached, dE by dt is going to be 0. So EM will be equal to 4P divided by CA. And when we are substituting it again in this equation, dE by dt plus ECA by 4V, and we are also dividing it by V, which is the volume of the room, will be equal to P by V. And C is the velocity, V is the volume. And we are going to substitute that CA by 4V is equal to alpha. Therefore, from this expression, what we get is 1 by V will be equal to 4 alpha by CA, multiplying by P on both sides. P by V will be equal to 4B alpha by CA. d by dt plus E alpha will be equal to 4P alpha by CA. When we multiply with E alpha t on both sides, d by dt plus E alpha into E alpha t will be equal to 4P alpha by Ca into e power alpha t. So this e alpha term becomes 0. dE by dt e power alpha t will be equal to 4P by Ca e power alpha t into alpha. So we are going to integrate this term on both sides. So integrating this term will give the same term e into e power alpha t. On integrating this term, the constant term can be taken out, which is 4p alpha by Ca and integral e power alpha t. When integrating e power alpha t, we get e power alpha t divided by alpha plus one constant of integration. The constant c is determined by the boundary conditions, and it depends and it changes for whether it's growth of sound energy or decay of sound energy. So growth of sound energy, the boundary conditions that we are assuming for the growth of sound energy is that K is equal to 0, E is equal to 0 at the boundary condition. So when we are substituting it, all these values, sorry, it should be T is equal to 0, E is equal to 0 at the start in the boundary condition. When time is equal to 0, we are assuming energy to be 0. Substituting these values in this equation, this whole term becomes e power 0, and E is also equal to 0. 4k into e power 0 by Ca plus k. So k will be equal to minus 4p by Ca. Substituting this term again in the first equation that we had, the general equation, that is this 11th equation, it would give us e power alpha t is equal to 4p into e power alpha t by Ca minus 4p by Ca. Dividing by e power alpha t on all the sides, we are getting E is equal to 4p by Ca times of 1 minus e power alpha t. We already have discussed that 4p by Ca will be equal to Em. Mm, Yeah, Em is equal to 4p by Ca. So again, we are substituting the same thing. That would give us, instead of 4p by Ca, we are writing it as Em, which is energy maximum. E is equal to Em times of 1 minus e power minus alpha t, which is the expression for the energy growth, energy density of sound waves. So when t reaches infinity, the energy reaches its maximum value. As we can see from the graph, when we plot this equation, E is equal to Em 1 minus e power minus alpha t. With time, the sound energy increases exponentially. Decay of sound energy. Assume that the sound energy has reached the maximum value, then we are removing it from the source, the power of the source becomes zero, which is the condition that we are going to be assuming as the boundary condition for decay of sound energy. So we are considering that T is equal to 0, P is equal to 0, and E is equal to E max. From energy maximum, the energy is going to drop down slowly. So substituting it in the first equation that we have, that is this one, 11th one, e power e alpha t is equal to 4p into e power alpha t by Ca plus C, mm, which would give us Em into e power 0, which is equal to 4 into 0, because this entire p term becomes 0 plus c. So which will give us c is equal to Em. So we can substitute this constant value again in the expression 11, which will give e into e power alpha t is equal to 4p into e power alpha t by Ca plus Em. So, like once again, P is going to be zero because P is always zero after the source is cut off. For the complete decay of sound energy, we are considering the fact that the source has been cut off. In any time after the source has been cut off, the power is only going to be zero. So, E is equal to Em e power minus alpha t. When we plot this graph, we can see that the energy from the maximum value is decreasing exponentially as time goes on. And this is the final formula of Sabine, which is P, that is the reverberation time, is given by 0.167 velocity, volume divided by sigma AS. Thank you.